A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where we shall today move ahead with the final portions of climatology and will enter into the area of oceanography. So, yesterday we studied about the Indian climate and the Indian monsoon. Today, we are going to take a look at the global climatic distribution and the world climate. So, just a moment. So, here, first of all, when we talk about climatic classification, which are the portions relevant here for the examination? So, this is going to be relevant only for your prelims preparation and only for your prelims examination. Now, I will show you the type of questions which have been framed from here, but just to tell you the basics about for the portions of the prelims, the basic areas about some of the climate types, such as the equatorial climate. Yes, Mega, that is going to happen. Equatorial climate, then savanna type of climate, then after that, British type of climate, then Mediterranean type of climate, then also China type of climate. So basically, these are the portions from where the type of questions will be that you will be given a certain amount of condition or certain type of condition, and as a candidate you are supposed to find out which type of climate is being talked about in this. So that is the requirement, that is the requirement of the question. Now here in this global climatic classification, we are going to study the Köppen's classification. In Köppen's classification, there are codes given for various different climate types. For example, you have A type divided into AF, AM, AW. Then you have BF or BWH, BWK, BSH or BSK, and like that. Okay, so like that you have various different codes for the different climatic types: CFA, CFB, CS. Like that you have different climatic codes for different climatic regions. These codes need not be remembered or rote learned for the examination. Please do not start learning these up. It is only by multiple revisions while you can internalize this. But please don't try to learn all of this, because that will further complicate that understanding of this chapter. And UPSC till now, for the past 10 to 15 years, if you analyze the trend of the questions, UPSC has not been asking about these codes. So please don't start learning the codes. Okay, some idea about A type, B type, C type, D type, and E type is required. That E type, for example, is a polar climate, H type is a highland climate. That basic understanding is still warranted for, but going into the depths and learning all these codes, that is not required for your examination perspective. All that you need to know if you want to go for selective studies here, this is a chapter where you concentrate upon these particular areas. When is it that rainfall is received? What are the climatic conditions observed? Why such climatic conditions are observed? Which are the regions of the globe where you experience this? That shall be more than sufficient. To add on to that, monsoon type of climate also you can add, but monsoon type of climate is something that we have already studied. Any particular characteristic that you can delineate for monsoon type of climate? Seasonal reversal of winds, occurrence of rainfall in the concentrated duration of 2 to 3 months. That is where maximum amount of rainfall will occur. These are the characteristics of the monsoon type that we studied yesterday also. So just understand these type of portions and you are good to go. So moving ahead, first of all, with this Köppen's classification. Now here, just to give you a background about it. Now, ever since mankind basically started exploring the world, and that goes back around to more than 2500 years, when Herodotus basically visited Egypt. And one of the first geographical analysis that he carried out was the formation of the Nile Delta, where he observed that triangular shape formed by the riverine deposits. Since that point of time, the study of geography has been carried out. Now, since that point of time, there was always this kind of a query, that kind of a curiosity in the minds of the people about the climatic conditions experienced in various parts of the world. We have talked about it in the first class also, that the ancient Greeks and the Romans also, they were aware before the Romans, the Greeks, they at that point of time, almost 2500 years ago, with the help of the various expeditions, they were aware that once you cross the Mediterranean and enter into the large sea, if you move to the north, you come across areas which are frozen throughout the year. So, which large ocean would they have ventured into? What do you think? Obviously, the Atlantic Ocean. It is the Atlantic Ocean that they would have explored and moved north. They would have traversed to the northern extent and extremities of Europe, and they would have basically seen that the Arctic region is permanently frozen. So they were aware of that. That led, at the time of Aristotle, for the devising of the various broader climatic zones. So Aristotle, for the first time, and the studies conducted during that period of time, that was responsible for the generation of the first climatic model. And in the formation of the first climatic model, here, you basically had the region of the tropics. In the region of the tropics, the average annual temperature, equatorial region included. So, when they would go into the region of the tropics, they would find the temperature and the conditions to be so oppressive. They thought human life cannot survive here. And that is where it was named as the torrid zone. Obviously, you have many civilizations living in this torrid zone, but at that point of time, much was not known. Then, between the tropics and the region of the Arctic, there the conditions were moderate. The temperature, the climatic conditions were never allowed to hit any extremities. So that is when the winters were not very cold, the summers were not very warm. So this was named as the ideal condition for the survivability of humans, and this was named as temperate zone. And then the frozen areas in the north and the south, they were known as frigid zones. This was a kind of the earliest classification which was done, and this prevailed. This kind of classification prevailed for more than 1.5 millennia almost, and even more than that. Now, by the time of 1800s and the 19th century, the era of discovery and exploration was at its peak. Each and every area was virtually being discovered on a day to day basis. Various climatic types, various species of plants and animals would surprise the humans on a day to day basis. Paleontologists would carry out new studies to find skeletons and remains and fossils of very ancient species which once existed and have been extinct. So, botanists, by that point of time, had carried out the entire detailed research and had compiled a very significant study in the form of an encyclopedia detailing the plant types across the world. What kind of plants are to be found in, let's suppose, India, within India also. The plant types that you find in the southern part of the country, the plant types naturally growing in the northern part of the country, or the eastern part of the country, or the western part of the country, they will be significantly different, won't they? You won't find the same plant species to be growing in the region of Andaman Nicobar also, and in the region of Madhya Pradesh also. There will be variation. So, an entire list was being prepared by a series of botanists about the natural vegetation of the world. Now, one of these botanists was the French botanist with the name of Candolle. Candolle was one such French botanist who prepared the entire encyclopedia of the natural vegetation. If I simply write natural vegetation, after some time, those of you who have the habit of listening it on mute will think that a type of natural vegetation is known as candole. So it is not. So French botanist who prepared a list of all natural vegetation of the world. Okay? Of all the natural vegetation of the world. Now, here, when we talk about this natural vegetation or plants which grow naturally in an area, on what conditions do the plant grow? Or why is it that desert areas have different plant types, and let's suppose the rainier areas of Western Ghats, they have different plant types? So basically, can we say that plant types or the growth of natural vegetation is dependent on availability of rainfall as well as temperature conditions? You cannot have a mango tree growing in the region of Siberia and northern Canada, right? Similarly, you cannot have a coniferous tree or a temperate vegetation growing in Andaman Nicobar or Sri Lanka. So, these were thought to be the conditions which would alter or determine the growth of plants. Now, you had a climatologist with the name of Vladimir Koppen. Vladimir Koppen basically looked at this compilation of the natural vegetation and he thought to himself that areas across the globe they experience different climate, and in order to understand the different climatic types, can we not base that climatic classification on the natural vegetation of that area? Because in a certain climate type only certain kind of vegetation will be observed. Grasslands won't be observed in the equatorial regions of dense or where you have heavy rainfall on a daily basis. Similarly, dense forest cannot be observed in dry areas. So, based upon this analysis of the vegetation distribution, Vladimir Koppen came up with his own classification of climate. Now, what he did was Initially, something very similar to the move carried out during the times of Aristotle, where he divided the entire planet into various climate types. He divided the climate into A type, B, C, D, E, and H. On this basis, now, what was A? What was the region of B? What was the region of C, D, E, and H? First of all, A type. A type would represent the regions amongst the tropics. That is, from Tropic of Cancer in the north to Tropic of Cancer in the south. So this would represent tropical climate. Now, in tropical conditions and tropical climates, we can say average annual temperature is higher than 18 degrees Celsius throughout the year, isn't it? Generally, moisture is also available. It might be available throughout the year around equator in the region of southern India, for example, or majority of the parts of India. It might be available due to monsoon, like that. All of them were included in A type. Then, as you would move away from equator, you would come across the tropics, the subtropical high pressure. The subtropical high pressure region of the world are dominated by which kind of terrain? Which kind of topography dominates the subtropical high pressure regions of the world? We have talked about it. Very good. Dikshit. Mega. Correct. They are dominated by deserts. Correct. They are dominated by deserts because of the high pressure condition. There's a substantial lack of rainfall. So, this B type would represent arid and semi-arid areas where you don't have dense vegetation at all. Now, the extremity of these areas would be deserts like the Sahara and the Atacama. And then the moderation of this condition would be an area, let's suppose, where you receive rainfall for 1 month, little amount of rainfall because of frontal cyclone development, like Mongolia. Now, there, if you have that little amount of rainfall, you will observe what? Growth of grasses, very small grasses. And that too, for a duration of 1 or 2 months, again, it would be barren. Think about the regions such as Kazakhstan, Mongolia, etc. So this would be the dry climate. Dry climate, representing arid and semi-arid areas. Good, very good. See, if you apply this kind of a logic, you will be able to cover it easily. Otherwise, even I'll tell you, before the prelims, 1 week before the prelims, my inbox gets flooded by the mails from various candidates that can you tell me a shortcut for covering this topic, or can I leave this topic? All they want to hear from me is that statement that don't read this topic, you will be fine. But I cannot say, because every year, almost every other year, UPSC does ask you one question from this. Nowadays, UPSC has started mixing this area with the portion of environment also. So that is why UPSC does ask this, but apply logic, it is easy to solve. C type, further away from equator, from B type also, from the subtropics further away that you move. Think about the northern hemisphere, first of all. You move to the region of the temperate areas, where the winter is around 8 degrees Celsius to 10 degrees Celsius, maybe 5, 6 degrees Celsius. Summer is around 20, 22 degrees Celsius. Neither extreme winters nor extreme summers. So that is the temperate condition. Rainfall can happen in this area almost for throughout the year. Or, such as in Britain and Western Europe, rainfall can happen throughout the year. Which permanent wind system, by the way, is responsible for bringing rainfall in Western Europe throughout the year on a day to day basis? Which wind system is responsible for that? Beautiful. Very good. It will be the westerlies and the marine influence, the marine air mass. Now, that allows the temperature to remain moderate, right? So, that is the temperate climatic condition. No extreme conditions, moderate winter and summer. Yes, my dear friend, what is it? Radhika, you have written, sir, please. What is it? Is it already bouncing above the head or is it something else? Please let me know. Because if such a panic alarm is there, something must be bothering. Okay, torrid zone. Torrid zone is basically the earlier climatic classification which was done at the time of Aristotle. That is when the planet was classified into torrid, temperate, and frigid zone. Torrid zone would be the region between the tropics where the temperatures would be very torrid. Torrid is an English term. Just look up into the dictionary about the meaning of torrid. I hope you guys are aware about the meaning of torrid, right? Torrential, the word torrential also is a derivation of this. So torrential rainfall, when you hear, what is it that comes to your mind? Extreme amount of rainfall. So torrid zone would represent extremities of climatic conditions in terms of heat, because the Greeks at that point of time, when they would go into this area within the tropics, they would find the climatic conditions to be very hot, and they thought that it would never be suitable for survivability of humans. That is where they were wrong. But nonetheless, because of extreme climatic conditions or extreme weather conditions, this was classified as torrid zone. Is that understood now? But Radhika, I would still suggest open up the dictionary, type the word torrid, and take a look into the meaning of torrid. Is that understood? Do you want me to write it down? I hope you don't choose that option. Okay. So here, within tropics, very high temperature. Okay. Now satisfaction would come. Then the D type of classification. Now, by the way, this is the old classification. Don't get confused with this, that this is the Köppen's classification. No. D type. So basically, let's suppose the regions such as Canada, central northern Canada, regions such as, let's suppose, the central eastern Eurasian region, Siberia. Now, even though they are at the latitude around 45, 50, 60 degrees, they would experience very cold winter. Temperature in the winter can easily dip to -5, -10, -15 degrees Celsius. During summer, the temperature would be anywhere in the range of around 5 to 10 degrees Celsius. So, these would be the cold forest regions, interior of very cold winter. This is also what is known as taiga type of climate or taiga vegetation. Here, basically, You will observe in these areas the growth of coniferous trees. And these coniferous trees, they are referred to as taiga vegetation. Then you have the E type. E type is the polar region, polar area. Now, let's suppose Greenland. Greenland also comes into the polar region. Now, in the coastal areas of Greenland, still you will experience some moderation in climatic conditions due to the melting of ice due to the marine environment, right? So maybe sometimes vegetation will be experienced during the summer. But the interior areas, they would remain frozen throughout the year. The region of Antarctica would remain frozen throughout the year. So this would, E type would represent polar climate. Polar climate. Now, this would classify the climatic conditions across the globe. But Vladimir Koppen was also aware of the fact that when we talk about the climatic classification, let's suppose a region such as Uti, which is present almost at a similar latitude as, let's suppose, a Chennai or very close to that in terms of the latitudinal extent. Chennai will experience a very different climatic condition as compared to Uti. Agra and Darjeeling at the same latitude experience variety of different climatic conditions. Why? Because Darjeeling and Uti are situated at an altitude. So areas which are situated at an altitude, they will always have a different climatic condition as compared to the areas which are situated at the sea level. So how do you classify that? So that is why all these areas which were situated at an altitude which would experience different climatic condition, they were classified into H type, or what is referred to as the highland type. Highland type. So here basically areas situated at an altitude due to which climate is different. So the broader concept, I hope, is understood, that how is it that Vladimir Koppen classified the climatic conditions. It is based upon the distribution of natural vegetation, because he thought that natural vegetation is dependent only on rainfall and temperature conditions. Only later on, when his students basically also looked into it. So Vladimir Koppen came up with this in the 1900s. Now, it was when his students basically they worked further. That is when it was understood that vegetation is dependent on many factors, on the rate of evaporation also. A region might have a very high amount of rainfall, but evaporation can be equally high. Dry vegetation would be found there. So that is when this Koppen classification was later modified. It was Koppen, Geiger, Pohl. That classification eventually entered into the fray. But that is not relevant for your general studies portion, not required. Multiple other climatologists also came up with their own climatic classification. You had the classification done by Thorndike, classification done by Trivartha. Again, not important for your GS, so we are not going to study that. So for your GS, we are just going to study the Koppen's classification, which is relevant for the paper. So I hope overall understanding is there that on what basis this classification was done. Now, A type, humid tropical climate, warm and moist conditions throughout the year, and mean temperature always above 18 degrees Celsius. That is included as A type. B type, dry climate, where the amount of evaporation is always going to be higher as compared to the amount of precipitation. Then C type, mild winters, average temperature of the coldest and the warmest month between 8 to 18 and 22 degrees Celsius. So, neither extremities of cold condition nor the extremities of warm condition. D type, average temperature of coldest and warmest month. Warmest month will be 5 to 10 degrees Celsius. Coldest month will be -3, -5, -10 degrees Celsius. And then E type, polar climate characterized by summerless season. So that is the case of entirety of Köppen's classification. But Köppen was also clear with the fact that, look, when you talk about the region of the tropics, equatorial area, which also lies in the tropics, will experience rainfall on a daily basis. And let's suppose you consider the region such as the southern part of India, which also lies in the tropics. There you will have rainfall during the monsoons. Otherwise, they will be comparatively drier. Then let's suppose if you consider in India itself, if you consider the leeward side of Western Ghats, that is the Vidarbha region of Maharashtra, the northern portion of Karnataka, the regions of Telangana, the regions to the northwestern portion of Andhra Pradesh. Now, what is the climate that you observe here? Dry conditions, very less rainfall. For example, western part of Western Ghats will receive very high amount of rainfall, dense vegetation. Mangalore, then let's suppose Goa, Ratnagiri, Gokarna, very dense vegetation. But let's suppose if you consider the region in northern portion of Karnataka, Telangana, Vidarbha, etc., grasses, dried grasses will be there. So all of them are within the tropics itself. But while at equator you receive daily rainfall, in Mangalore you receive rainfall during the summer months. In some other area in the interior of Karnataka or in the region of Telangana, you have a distinct dry spell and a wet spell. So what does that tell you? It basically tells you that there needs to be a further subclassification. And there also, let's suppose we consider Europe. Now, most of the portions of Europe will lie under C-type, temperate region, moderate climate. But western portion of Europe, which is receiving daily rainfall due to the maritime winds, let's suppose the maritime winds brought by the westerlies, they will have moderate climatic condition. Extremities of temperature won't be reached. But simultaneously, let's suppose if you consider the region of Central Europe, extremities of climatic condition would be reached. So temperature will also not be consistent at the same latitude. Temperature will also vary at the same latitude, isn't it? So that is why for further classification, Köppen used smaller alphabets, where he used F to indicate a situation where there is no dry season, where there is rainfall throughout the year. F type. For example, can we say that British type of climate will receive rainfall throughout the year? We can say that. Now, the region of Britain lies in the temperate area. UK lies in the temperate area. So you will attach CF. And the climatic temperature is not to the extreme. So CFB. Why? Because A, B, C, and D, they refer to the degree of severity of temperature. Like that coding is done. This is for code delineation. M, monsoon climate. Monsoon climate means what? High amount of rainfall is received in those 2 to 3 months of the summer season. Right? So that is M type. For example, western part of Western Ghats, the region of Agumbe, the region around Kudremukh, the region around Mangalore, very heavy rainfall. Malabar coast, very heavy rainfall. But most of that rainfall is during the monsoon months. It is within the tropics. So AM will be the climatic condition of that area. Then W, no rainfall in winter. Telangana, Karnataka, Vidarbha, no rainfall during winter. For most of the year, it is dry, very short rainy season, and then again dry. That is why dried grassland. So that will be termed as AW. So winter dry means rains only in summer. And then S type means summer is dry, means rains will be received only in winter. In winter. With the help of these and these smaller letters and these bold letters, there was this entire codification done for the climatic classification, which was distributed across the globe. Lakshmi. Sir, in A type, above 18 degree, uh, in A type, above 18 degree, in C type, 8 to 18 degree and 22 degree. Point not clear. Read the point carefully, Lakshmi, and tell me what is not understood. Read the statement carefully. A type is those regions where the conditions are warm and moist throughout the year and mean temperature is always above 18 degrees Celsius. Means regardless of the season, average temperature will be above 18 degrees. It can be 35, 34, 33, 32. In every season, it will be above 18 degrees. Here, mild winters, no extremity of temperature. Average temperature of the coldest month will be between 8 to 18 degrees Celsius. So winter will have a temperature between 8 degrees Celsius to 18 degrees Celsius. So no extreme winter. It is not as if winter will be minus 2 degrees Celsius. No. It will be between 8 to 18 degrees Celsius. And summer will be not more than 22 degrees Celsius in the C type. Means what? You have a moderate climate. So winters are in this range, 8 to 18 degrees Celsius. Summers are maximum up till 22 degrees Celsius. Is that understood? Okay. Prerna, how question will frame from this? Question will be framed that this is the condition experienced in an area. Which type of climate are we talking about? Equatorial, savanna, Mediterranean, monsoon, this type of a question. Vibhu, a single place can have multiple codes? Generally, no. Generally, no. Because it talks about the climate, not the weather. I hope we are able to distinguish the difference between climate and weather is basically what you experience on a day-to-day basis. Right now, for example, in this month, you might have one day which will be very sunny. So the weather will be that today's weather is sunny condition with slightly higher temperature. But the month of January is winter. That is the climate. Okay. F always go with A type? No, it goes with C type also. It goes with D type also, Ankush. Does it also include nighttime temperature? Yes, a long-term average. I didn't get the name you gave to the regions. Which name did I give to the regions, my dear friend? Ram? Which kind of name are we talking about? Please let me know. I will help you understand. So that is the case of the Köppen's climatic classification. Here, if you observe the trend, closer to the equator, you will always have the presence of A type. Further away from equator that you go, you will always find the presence of B type. These are your B type regions, dried areas. Then you will find C type. In the coastal areas, you will find the presence of C type here, moderate climate. This is your D type, extremities of winter conditions, very cold. and then you have the polar climate, frozen conditions. That is your E type. So that is the significant different classification of Köppen. Okay. So let us take a look at each one of them one by one. And here again, rely on the PPT itself. Again, I will repeat, please don't try to learn the codes. UPSC doesn't ask you the codes. UPSC asks you a generalistic question frame from this. So please don't try to learn the codes. So starting with the A type. A type is basically the region in the tropics where the amount of rainfall received is very, very high. Now here also, there is multiple subclassification. So tropical climate basically means the areas between Tropic of Cancer to the north, Tropic of Capricorn to the south. That is the A type of climate. Now this is a tropical humid climate which exists between Tropic of Cancer and the Tropic of Capricorn. The sun being overhead throughout the year and the presence of ITCZ, it makes the climate hot and very, very humid. So the climate becomes hot and humid. Annual range of temperature is very low. Annual range of temperature means what? The difference of temperature between the summer and difference of temperature in the winter. That is the annual range of temperature. So if the range is less, means the summer and the winter temperature is not very different. For example, in Mangalore, in Chennai, summer conditions, summer temperature is 35, winter temperature is 20 to 25. Right, Delhi, summer temperature is 42, 45, 47, winter temperature is 2, 4, 5. So great variation. So here, annual range of temperature is low means what? Very little variation. Variation between summer temperature and winter temperature. And why is that the case? Why is it that there will be very little variation between the summer and the winter temperature between the tropics? Because throughout the year, in the region of the tropics, the amount of solar insolation will consistently be on the higher range. So there will be always a higher temperature. This is because insolation is high. Along with that, you will also have the case where precipitation or rainfall moderates the temperature. Please understand, one thing that you have to keep in mind while studying this is that this is not a perfect climatic classification. This classification that you are studying was basically devised in 1900 itself. So there have been a lot of modern modifications which have been made, which is not relevant for the GS, so we are not venturing into that area. So it has got some loopholes, some lacunae here and there. So when you study this, when you apply this to the nearby areas and the vicinity across the globe, have that reality check in mind. By the way, are we aware about the term diurnal range of temperature? I think we have talked about it. Diurnal range of temperature, what is it? Very good. Beautiful. So this is the difference of temperature between night and day. Night temperature and daytime temperature. That difference of temperature between nighttime and daytime, that is the diurnal range of temperature. Now here, in this tropical type of climate, you will have the annual rainfall is high. Annual average rainfall, if you consider, that will be always on the higher end. Now, this is divided into three types. You have AF, AM, and AW. You don't have an AS because in this area, tropical area, during the summer, you do receive rainfall. Either as monsoon rain or as convectional rainfall, you will receive rainfall during summer. So you don't have AS. So AF means rains throughout the year. Throughout the year. So which area experiences that? The regions of equatorial region. No, western coast doesn't receive rainfall throughout the year, Amritansh. Then, tropical monsoon climate, where maximum rainfall during monsoon months. Then AW, here, very short spell of rain during summer. Winter is dry. So will you find dense vegetation in AW type? Do you think you will be able to find dense vegetation in AW type where you have in general a scarcity of rainfall? No. So what do you observe here? You will observe the presence of grasses, grasslands, right? For example, that is where I was giving the example that when we talk about the region of Telangana, if you move outside from the vicinity of Hyderabad, you venture into any area, or the Vidarbha region of Maharashtra, or let's suppose the northern country, you will find the presence of grasses also, dried brownish grasses, which during the rainy season it will become very green, new lush grasses will come, but again for most of the year it will be dry. Why? Because the rains received in this area is very less. That too, during the monsoon period or during the summer months, some amount of rainfall will be received, but not very high. High rainfall can always support dense vegetation, not less rainfall. Okay. Now, in India, where can we find rainfall throughout the year? Some portions of Nicobar Islands. That is where you can find rainfall throughout the year. And also in some portions of Lakshadweep also. Okay. Where these codes are used and for what purpose? What do you think? What does your imagination tell you? Is it a code for International Space Station where they will feed this code? What do you think? This is to classify the climate. This is, again, I will reiterate, this is the Köppen's classification done by Vladimir Köppen to understand the global climate. How, if you have to tell someone, if someone asks you, describe about the or classify the global climate, how will you do it? What will be your approach to classify the global climate? Will you start saying, in let's suppose in India also, let's leave the entirety of the world. If I ask you classify the climatic conditions in India, on what basis will you classify? Always you will denote some of the characteristics that, okay, Rajasthan, dry area, let's name this X. Then Ladakh also dry area, but cold dry area. Let's name that X1. Then Cherrapunji, very heavy rainfall. Western Ghats, also very heavy rainfall, but both of them are not same. So that is why for classification of the climate, these codes were used in order to identify them. It is not that somewhere these codes will be used, it will be fed into the computer will give you a good program like that. No. It is just a global classification of climate with which you can understand the global climatic distribution. Is that making any sense at all? How many of us are totally overwhelmed by this code? That is why in the first PPT, on the first slide itself, codes need not be learnt. Need not be learnt. Is that clear? Okay. And have some patience. We will study various different climatic types. You will have a better understanding what these letters denote. AF. A means tropical. F, rainfall throughout the year. For example, in the equatorial areas of Peru, Iquitos in Peru, observe here this particular graph. This particular graph will represent the condition. Here, these bars represent rainfall. So there is rainfall throughout the year. January, February, March, April, May, June, July, August, September, October, November, December. In every month in the equatorial area, you do receive rainfall. Average monthly rainfall is around 25 to 30 centimeter. 20 to 30 centimeter can be taken as an average. Observe the temperature. This is your temperature. Temperature is consistently between 25 to 30 degrees Celsius for every month. So, occurrence of daily rainfall, moderate temperature means very little variation in temperature range. So that is AF. A, tropical. F, rains throughout the year. So here, if it is raining throughout the year and the conditions are, let's suppose, 25 to 30 degrees Celsius, will you experience a dense vegetation or will you experience a kind of a dried forest in this area? What do you think? What will you experience here? Very good. Very dense vegetation. Very dense evergreen vegetation. Amazon rainforest. Congo rainforest. Then the Indonesian rainforest. In these areas, you'll find AF type. So precipitation occurs all the year round. Variation in temperature is less than 3 degrees Celsius, means the difference in temperature between different months is less than 3 degrees Celsius. Humidity is extremely high, which maintains the temperature also. And the surface temperature results in the formation of cumulus and cumulonimbus clouds in the early afternoon on a daily basis. This results in high rainfall. Which kind of rainfall? Convectional rainfall. Rains. So here you will find dense evergreen vegetation with a very broad canopy cover. What is a canopy cover? So here, let's suppose this. So this thing that you see of a tree, this is what is known as canopy cover. This is what is referred to as canopy cover. Okay, that is what is referred to as the canopy cover, canopy coverage of any tree. Okay, now here almost it is at the region of equator, so almost equal length of day and night. It is not always going to be equal, but almost. It is not as if nights will be very long or days will be very long, almost equitable. So in the region of Peru, Amazon River Basin, Congo River Basin, Philippines, Indonesian region, that is where you'll find the presence of AF. Here, this rainforests in Amazon, these are also known by the name of selvas. Okay, that is the name given to the forest in this area. This is the region of very dense biodiversity, very unique form of biodiversity. Generally, in dense vegetation, I hope you are aware, if the vegetation is very thick, very dense, you won't find many large animals. For example, in very dense vegetation, you won't find many of the elephant species, rhinos, etc. You won't find. But here you find all of them. Why? Because it is said at one point of time when the region of Indonesia was joined with the rest of the Eurasian landmass, that is when many animals went over. Then when the melting phase of the or melting phase came where the ice was melting, interglacial period, that is when the sea level rose, isolating these islands from the mainland, and the species they got stuck there. That is where very unique kind of species, the Sumatran tiger, the Sumatran rhinos. If you take a look at Sumatran rhinos, very small in comparison to the Indian rhinos, right? Sumatran elephants, again very small as compared to even the Asian elephants, which are the smaller counterparts of the African elephants. Very unique kind of species. But this is the region which is experiencing one of the largest rates of deforestation of evergreen forest anywhere across the globe. Every year, thousands of hectares of pristine, natural evergreen forest land they are cleared. Can you guess the reason why? Why is it that such large scale of deforestation is being carried out in that area? Take a guess. Not timber. Timber is one of the outcomes of it. Tourism, no. For wildfires, why will you carry out deforestation? In order to carry out one activity, agriculture, and that too for one type of agriculture where only one kind of trees are grown, and that is palm oil production. Indonesia is the largest producer of palm oil across the world. It is one of the major exporters to India also, right? So that oil palm cultivation, in order to carry that out, oil palm is used in almost each and every product that we use on a daily basis, from many of the packaged food items to, let's suppose, the cosmetics that you use, the cold creams that you use this season, everything uses some or the other degree of oil palm. So that is basically, for the cultivation of this, you have the clearance of forest being carried out in Indonesia, where various scientific communities, various climatologists, they have raised the alarm already, but then it is still being carried out. So that is the case of the AF type. Now the AM type. So that is the tropical monsoon climate. Now monsoon climate means what? Rainfall is received during the hottest of the months. That is when the monsoon comes in. So basically, annual amount of rainfall is similar to that of AF. In AF, you had rainfall which was distributed throughout the year, but look at the average rains. 25 to 30 centimeter of rainfall every month. Fair enough? 25 to 30 centimeter of rainfall every month. I'll show you the monsoon type. Observe here. Amount of rainfall received during the monsoon months in Mangalore for the month of June and July itself. How much is that? 80 to 100 centimeters in 1 month. Agumbe, in the western part of Western Ghats, is the second most rainiest area across the globe. So the rainfall received is very high, but is concentrated only during these monsoon months. So precipitation usually occurs within the summer season. During the rest of the year, there is very little amount of precipitation. Winter is dry, found over the Indian subcontinent, northeastern part of South America, northern Australia, which also gets influenced by the monsoon. Heavy rainfall occurs mostly in summer. Here, generally, you will find the dominance of deciduous trees. Along with evergreen, also, you will find, but deciduous trees. Why deciduous? What are deciduous, by the way? Deciduous trees are those which will shed their leaves during the dry season. Because through the leaves, the plants will consistently lose water. Through the pores in the leaves, the plants will consistently lose water into the atmosphere. Okay, so the deciduous trees, basically, they will be the ones which will shed their leaves during the dry season in order to conserve that moisture in the soil. And that is where they will appear as a dried out forest. Again, the rainfall comes, all the leaves will regenerate, it will appear lush green again. So because of the monsoonal climate means that it is dry in many parts of the year, so that is why deciduous trees will dominate. We'll study in Indian geography, there's a further subclassification into moist and dry deciduous also. So these shed their leaves during the dry season. Leaves during dry season. Okay, now we have seen the climatic condition here. Average temperature is almost consistent, but rainfall is very, very high, almost equivalent to equatorial climate. But all that rainfall is concentrated within 2 to 3 months. So instances of flooding, etc., will also be very common. So these are the areas typical of monsoonal climate. Now we come to AW. AW means winter is dry. Okay, so here winter is dry. Maple tree you won't find in tropical climate, Lakshmi. Maple trees that you find will mostly be in the D type of climate, where the conditions are colder. Not much of the in tropical. Some areas you might find, if hill stations in the tropical areas, you might find maple, but otherwise, near closer to the sea level in the tropics, you don't generally end up finding maple. So here, winter is dry. It rains for a very short duration. Now, observe the kind of vegetation here: dried grasslands, which during the rains will have lush green appearance. The grasses will grow with a very rapid rate of expansion. But during the summer, it is going to be that brownish appearance in these grasses. That is the AW. So, very distinct rain and the dry season. The rain spell is very less. Now, during the dry season, think about it, this is an area. During the dry season, apply your logic here for a brief moment. Daily variation or diurnal range of temperature, that variation will be high or low. Means, will there be a high difference between the daytime and the nighttime temperature, or will the daytime and nighttime temperature will be equivalent? Very good. Beautiful. That difference of temperature between the daytime and nighttime, that will be very high during the dry. Why? Dry lapse rate. Clear sky, so heat loss will be very fast during the nighttime. Nighttime temperature will be lower, daytime temperature will be higher. For example, these are also the regions of tropical grasslands. Tropical grasslands, which are known as savanna. The Masai Mara region in Kenya, Tanzania, the Serengeti area in Tanzania, Masai Mara area in Kenya. It is here where you will find large species, the zebras, right? Herds of wild buffaloes, various different varieties of deer population. And where you have such large herbivores, you will have carnivores also. So, lions, cheetahs, all of them, jaguars in certain area, you will find them. Why? Because they need an open space, a comparatively open space. Here, for months altogether, the conditions remain so very dry that you'll find that, for example, species such as elephants, many of the varieties of, for example, even wild buffaloes, wild ass, they migrate through these areas for hundreds of kilometers in order to seek for some amount of moisture, some water. Everything turns very dry and the grasses, they dry out. Dried grasses are predominant. Dust storms become very common. That is where you will find the elephants even stomping out the trees, breaking the trees in order to extract the moist bark from within so as to fulfill the requirement of moisture. They will consume any green sapling of a tree which starts to grow. That is where the elephants, they are also known in environment ecology, you will study. Elephants, they are also known as the natural gardeners. Why? Because what do the gardeners do? They don't allow any excessive growth to happen. The elephants, with their weight of the feet, they basically stomp out any new tree sapling which is growing, or they will root it out, uproot it out, maintaining that grassland ecosystem. But it is the dry condition, scarcity of water, which is not allowing these vegetation to be very dense. Now, this region, let's suppose, it has experienced 5 to 7 months of very dry condition, very dry condition. Then, before the rainfall, you have dense cumulonimbus clouds getting created. Now, because there is so much amount of dust and dust storm, there will be lightning. And when lightning occurs and there are dried grasses spread across hundreds of kilometers, what do we observe? Wildfires, natural wildfires. They are a commonality in this area, which again don't allow many trees to grow. And again, as soon as the rainfall comes, within a duration of 1 week, everything turns into lush green. And again, after that short duration of 1 or 2 months, dry conditions prevail. Okay, that is the case of AW, or the savanna type. So here, if you observe, you will observe that it is during the summer that some amount of rainfall is received. It is basically in the region of Brazil, southern hemisphere. So that is where some amount of rainfall is received during summer. Now here, these grasses, these regions of grasslands, they are spread in many parts of the world. You have the Sahel region in the region of Africa. I hope we are aware about the Sahel region. Sahel region is a transition between the Sahara Desert on north. So here you have the Sahara. Here you have the Congo rainforest. And this is the Sahel region. This is the area around Katanga Plateau. Today, you can spot it on the map also. You have the Katanga Plateau. In this area, there also you'll find grasses. This is where you will find Campos. These are the grasses in the Brazilian highlands. So this is the region around Katanga Plateau. Very high production of copper, lead, everything is very in large resources are present around the Katanga region. Locate it on the map. This is the region of Brazilian highlands, again rich in sources such as tin, right? So here you will find the presence of campos. The grasslands are named as campos. They are also found to be present in the region of Venezuela, where they are named as llanos. So that is the name of the tropical grasslands. In India also you will observe this. I told you in the region of the Telangana, Vidarbha area, northwestern part of Andhra Pradesh, and even in the northern Karnataka, you will experience this. Right? For example, any of you, if ever you have visited, I don't know in the correct analogy, but let's suppose those in the northern part, if you have visited the Ranthambore Tiger Reserve, and in the southern part, if you have visited the region of either Tadoba Andhari or the region of Sheshachalam area or the region of Bandipur Tiger Reserve, these are forested. But within the forest, you will find large expanse of these grasslands. The grasses are so very tall that an adult human can basically hide in these grasses. Ideal camouflage or protection for the tigers. These grasses are brownish also. That is where spotting the tiger becomes very difficult, right? So that is the kind of savanna grasses. Okay. So that is basically, yes, in Gir region also you will experience this. Gir is more on a much more drier of this, but yes, a similar characteristic even in the Gir ranges. Dandakarane is still having a dense forest. Dandakarane still will have some dense forest. Nowadays, it is turning out to be drier. But I hope you understand the larger aspect. Lonavala is lush green because of the altitude. Bandipur is the ideal example for this. Okay. So AW. Here, the wet season is shorter, that is, the rainy season is shorter, and the dry season is longer, with the drought being very severe. Temperature is high throughout the year, and the diurnal ranges of temperature are greatest in the dry season. Diurnal range means daily variation is high during the dry season. Why? Because of significant lapse rate. Tall to short continuous grasslands with scattered trees, deciduous forest also. Northern and eastern India, internal Burma, Llanos in Venezuela, Campos of Brazil, Sahel region, the Katanga Plateau region, you'll find the presence of AW. Then, after this, we come to the dry climate, B type. What causes rains in this area? In these regions, rainfall is caused by the shifting of the ITCZ, that is AW type shifting of ITCZ, occurrence of monsoon. Many of these areas are on the leeward side, hence receiving less amount of rainfall. Okay. Now, Indian grasslands, they don't have a different name like that. No. They have localized name given. For example, in Gujarat, you have the Bunny grasslands, etc. But you don't have a typical name given. For example, the Masai Mara region of Kenya or the Serengeti region of Tanzania. Here you have many such subvarieties. Now you have the group B or the dry climate. Now this dry climate, here you will have evaporation exceeds precipitation. So throughout the year, moisture deficiency is experienced. Deficiency is experienced throughout the year. Okay. So that moisture deficiency is experienced throughout the year. Now, some of the driest deserts of the world. By the way, are we aware about the most populous desert in the world, where the population is the highest? Which is the desert of the world where the population is the highest? Are we aware of that? Very good. Dikshit. Rani, correct. Bandana, correct. Checha, RN, correct. It is a Thar desert. Thar desert in India has got the highest population in terms of density, in terms of distribution, but Sahara overall, very sparsely populated. Many areas are not even populated enough. Now here, when you take a look at this B type, there are further subclassifications. Having said that, overall, this B type of climate covers close to around 1/4 of the area across the planet. 1/4 of the area across the planet. Okay, so around 25-26% of the land across the planet is drier. So dry climate are characterized by low rainfall that is not adequate for the growth of plants. Very large diurnal temperature range means variation of daytime and nighttime temperature is very high. Why? Because of dry lapse rate. Clear sky, loss of heat is very fast. Evaporation and transpiration play a greater role in shaping the vegetation state as compared to temperature because moisture deficiency is the resource in stress here. Now here further subclassification is done for these dry areas because these dry areas in certain parts you will have semi-arid grasses. And in certain areas you will have dry desert, absolute dry desert, like the Sahara or the Thar. Now, these are what are known as S. Here, S as a letter is attached. In this, as a letter W is attached. Okay, so this will be BS, this will be BW. Now, there is a further subclassification based on the average annual temperature. Average annual temperature. If the average annual temperature is greater than 18 degrees Celsius, a letter K is attached. Or rather, here, a letter H is attached. If it is less than 18 degrees Celsius, letter K is attached. So a dry desert, which is a hot desert, so hot desert, like the Sahara, will be named as BWH. A cold desert like the Gobi Desert in the Central Asia, that will be BWK. That is how, in this case, naming is done. Again, you don't have to chase the codes here. Please don't chase the codes, otherwise you will lose all the sleep at night. So basically, this is the case of the desert areas or the dry regions in general. This is BWH and BWK. So these are your cold deserts. For example, you have the Atacama Desert, right? And here the Patagonian region. Then you have the Gobi Desert. Here the hot deserts, the Thar Desert, the Rubal Khali Desert, the or rather Dastelut Desert, the Rubal Khali Desert, the Sahara Desert, all of them, the Victoria Desert. These are the warm deserts and the cold deserts. So starting with BW or the desert type, so these are the areas which cover around 12% of the global land. So that spans about 12% of the Earth's total land. Now, the plants in this area, they have modified themselves to adapt to very little amount of water availability or moisture availability. Now, the plants generally tend to lose moisture through the pores in their leaves. Here, the plants don't have leaves. Rather than leaves, they will have that green pigmentation in the stem itself. So that is why the stem appears green. Now, these stems of the plants growing in deserts, by the way, are known as xerophytes. That is the name associated with the plants growing in the desert area. So the stem is where the food is manufactured. You have a pulpy stem, which can store some amount of food as well. Now, that pulpy stem can have the animals easily eating into them like fruits. So the plants will never be able to grow. So for that protection mechanism, the plants, they grow thorns. On the stem, the pulpy stem, you will have the thorns also. So these are the adaptations that the plants go through. The animals, for example, the animals you will observe, they have fur. Why? Because the nighttime temperature goes very low. So the animals, they develop a kind of a fur. Okay. Then you will observe, for example, the animals, most of them are nocturnal. During the daytime, they don't venture out because the daytime temperature is very high. They are active during the night. You have few species of frogs, for example, who are able to assimilate and accumulate water in the form of dewdrops, which occur during the night, winter night. So that moisture they are able to assimilate. You have few species of lizards who go without consumption of water throughout. And that requirement of water is fulfilled by consumption of insects. And then majority of these desert animals, they will not urinate in liquid. Even the urine that they pass will be solid, so as to extract as much water from it as possible. So all the species have adapted accordingly to basically survive in this type of climatic condition. Okay. Now, example of this BWH, hot desert type of climate, in Tindouf in Algeria, where you observe precipitation almost being absent, rainfall, the temperature significantly going high during the summer, but temperature overall is going to be on the higher extremity. Then you have BS, semi-arid. These are the areas slightly beyond the subtropics, where still sometimes frontogenesis or frontal rainfall can occur. Okay, so some rains are caused in these regions by frontogenesis and sometimes even a temperate cyclone which moves through the area. Sometimes even temperate cyclones which pass through. So here, when you have these conditions, small grasses, not to the size of the savanna, small grasses might come into existence for a very short duration, for example, in the region such as Mongolia. Typical occupation, even in the Patagonia Plateau, for example, typical occupation is animal herding, where people will have a lot of animals, right? Milch animals in certain cases also. Hunting and gathering is still very prominent. It is in these areas where you will come across the hunters in Mongolia, where they hunt with the help of the eagles. So when that grasses they start coming in, they basically feed their animals upon that, and they utilize those animals for the availability of milk, for the availability of their skin, for the availability of their meat to be sold in the market and gain some revenue. So that is the case of B type. So it is steppe or a semi-arid climate. spans about 14% of the Earth's land and makes up the grassland type. Okay. These regions receive more rainfall than their BW counterparts because of mid-latitude cyclone, the temperate cyclone. Rarely intertropical convergence, but that generally does not happen. It is almost negligible. This does not happen very regularly. Okay, so that is your steppe type of climate. From this, if I talk about the temperate grasses of the world, are we aware about the name of the temperate grasses of the world? If not, do locate it in the map today. Note it down somewhere, or it is noted in the PPT. In Central Asia, what is it known as? This temperate grasses are known as steppes. Then in North America, they are known as by the name, are we aware? Prairies. Very good. In Argentina, they are known by the name, beautiful, pampas. That is a type of grass, Rohit. It is not the name of the grassland. Then in South Africa, they are known by the name of veld. In the region of Australia, they are known by the name of downs. Very good. In the region of New Zealand, they are known by the name of Canterbury. So that is how this is named. Locate these across the world. You have puts in the region of Hungary also. So that is how it is named differently in different parts of the world, and you can locate it on the map also. Most of you would have read steppes, prairies, and pampas in your school days also. Wells, Down, and Canterbury might be a value addition. So, but you would have read. So, even if you recall things of the school or not, as is the case, most of us, we do not recall anything of the school. So kindly open up the atlas. Today from this, I hope you can have much more amount of map pointing. Then the BWK and the BSK, the colder areas, these are slightly situated farther away from the tropics. And here the conditions are cold. But it is dry. After all, B type of climate means dry type of climate because of extreme continentality. Remember, I told you while we were talking about the onshore and offshore winds. For example, this region, this area. How will rainfall reach this area? Very difficult, unless and until you have a frontogenesis. Very difficult, right? Similarly is the case of this region also, of the highlands. Here also, aided by the cold ocean currents, etc. So these are the areas which are generally very dry because of extreme continentality. Located near the center of the continent, limits the amount of moisture supplied from ocean sources. Without the moisture, precipitation simply cannot occur. Presence of mountains or these regions being situated in the leeward side also influences them with the rain shadow effect. Major expanse of mid-latitude deserts can be found to the east of the Caspian Sea, north of Himalayas, western US, and east of Andes in a narrow region around Altiplano in that area of South America. Mid-latitude deserts have greater range of both daily and annual temperature. So the daytime and the nighttime temperature will be very different. Nighttime will be very cold in these mid-latitudinal deserts. Gobi Desert, for example, right? The nighttime temperature will be very low and winters will be much harsher as compared to the subtropical region. Then we come to the moderate type, that is the C type. The temperate climate. Winters are not very cold. Summers are not very hot. Mostly across the regions of the coastline, eastern or western coastline of the continents. In the temperate areas, that is where you will experience them. Mostly, so form this kind of a trend analysis rather than learning, okay, this was BWH, that was BWK or BSK. If you get yourself indulged in that, you will never be able to captivate this. So always look at the major trends, mostly around the coastal regions of continents in temperate areas. In the temperate areas. So here, winter is not very cold. Not very cold. By very cold, we mean here not by the reference point of a Mumbai or a Chennai or a Bangalore, where we say that, okay, 10 degrees Celsius, it has never been colder than this. People start taking sick leaves from the office also. So here, not very cold means it is not in a sub-zero temperature. So winters are not very cold. Summers are not very hot. We'll study more about this, the C, D, and E type. Then we'll proceed to oceanography. Before that, we take a break. So we'll take a break for 15 minutes. We'll be back in 15 minutes and then we will continue. confirmation about the audio, please, guys. If the audio is clear and available. Arun, dear sir, is 10 months be more than sufficient for any optional? Absolutely, yes. For any optional that you are picking up, you should have a target of around 4 to 6 months. That is the target, inclusive of answer writing, inclusive of the previous year paper. And in optional, basically, the role of previous year questions is very high because many of them are repeated in terms of the areas and the portions. So, 4 to 6 months more than sufficient, provided a dedicated study is carried out. I'm doing well in weekly tests of all subjects, but my score is very dissatisfying in PTS. First of all, it is a good news that you are concerned about it. Many of them are not concerned about it. So that is the first good thing. So basically, understand, for example, in geography PTS, which was conducted, many of you scored very well in that. And that is a moment of pride for me. But many of you could not perform well because many of you had the expectation immediately after looking at the questions. Many of you have that urge to come to a conclusion that I don't know it or I know it because it is not as per the written paragraphs that you would have read in the books. So always spend time with the questions. That is very important. Get to know these questions. What can be the answer? You know the basics. Be very certain with that, that I know the basics. The answer is in front of me. It is up to me to reach the logical solution. Right. Now, let's suppose you have committed a mistake in the PTS. What should be your approach after that? Do you take the or take a look at the scorecard and get disheartened and slump back into your blanket eventually after that? No. After appearing for the test, take some time off, take a rest, watch a movie if possible, go out with your friends, go for that de-stressing exercise. Next day, pick up that question paper again along with the explanation sheet which is provided to you. Again, for let's suppose a 2 hour test, ideally you should spend 3 hours analyzing each and every question in detail. Why did you go wrong? Again, read the questions prima facie to think about it, that what could be the answer. Then look it up with the explanation. Why the explanation is saying some other answer is there. Understand it. Like that, for every 100 questions, easily 100 questions, 4 options. Easily, at the end of this analysis, you will come across 100 new sources of information or 20, 30 such new sources of information which you were not very sure of before the test. Write it down. Single lines. Underline those facts in single lines in an A4 sheet paper. Compile these A4 sheets. Put it in a file. I'm just telling you how to organize. You can have your own method. I'm just telling you one of the methods. Compile these and start revising these. So by the time that you reach the month of March, you would have had a good compilation of around 1,000 to 2,000 such kind of factual portions which you have spent some time upon, where if any question comes from that particular area, this time you are not going to make a mistake. That is how you improve. And let me tell you, I have come across many candidates from my own personal experience who during the test series they score around 130, 140, they don't get through prelims because that mental conditioning has not happened or some mistake happens. I have also come across many candidates consistently. They are in the range of 50 to 70 in the prelims test series. They keep on improving. By the end, full length tests, they start scoring in the range of 100, 120 consistently. And that is when you will find that in the prelims, they clear it with a good confident margin. So take this as an improvement every week. Take the test as an opportunity that today again I will get to test my mind that whether I can arrive at a logical conclusion. There will be certain tests where you will spend so much time you will run short of time. There will be certain tests where it will absolutely bounce above your head. More content for factual portions. So analyze it, gain from it. Okay. This chapter is little hard. Let me be more specific. This chapter is very hard. It is not little hard, it is very hard. And that is why I keep on telling you, for this chapter, all that you need to analyze is only a certain climate types in detail. In PTS, geography questions were mostly from current affairs, less from theory. I beg to differ. You had around 7 to 10 questions which were factual in nature. Remaining 30 questions were absolutely driven from basics. Why I tell you this data pointer? Because I have given the analysis video as well. And by tomorrow, you will get the analysis video of environment ecology also. In environment ecology also, if you have attended the environment ecology sessions previously, hardly there were 2 to 3 questions which you could put into the category of factual. Rest of them you can solve on your own. So that is where I will tell you again, please concentrate on those basic questions where you are getting them wrong, why you are getting them wrong. Okay. Bhimare, I even not covered static. Cover the static portion first. Be very thorough and don't have the approach while covering the static. Most of the students have that approach that, okay, this month I'm studying geography, next month I will study polity, after that I will study economy, then I will study history, then I will study environment ecology, then I will begin with the revision. No. By that point of time, geography and economy are long forgotten. So after every week, maintain that revision so that it is retained and cover that static very thoroughly as you can. There is nothing from outside of this which is going to be asked. It is just how frequently you revise it. There is only this difference between the successful candidates and the repeaters. That is how frequently you are able to revise. Now, coming back to the C type of climate. So when we talk about the C type of climate here, hot and humid summers and mild winters, no extremity of weather condition. Extremity of weather condition. Extending between 30 to 50-degree latitude northwards and southwards from equator. They are typically on the eastern and the western extremities of the continents. So the shifting of the pressure belts means in certain seasons the winds can become onshore and in certain seasons the winds can become offshore. So that is why the shifting of the pressure belts plays a very important role in the seasonal variation of rainfall, because the winds from onshore they can become offshore. So here, shifting of pressure belts. Belts influence the onshore and offshore winds, causing high or rains in different seasons. Sometimes summer season may feature convective thunderstorms and winter season may observe or experience mid-latitude cyclones or frontal rainfall. That is something which will frequent many of these areas during winter season, because recall, we had discussed about the fact that the formation or the frontogenesis in itself is going to be much more frequent during the winters as compared to the summer season. Okay. So these are the areas. Even the regions of Western Europe will be covered under this. UK, France, Denmark, Belgium. They will be covered under this. The regions around Mediterranean will be covered under this. So this type of climate experience in this region, this is your British type. The type of climate experienced here in the region of the trade winds are onshore here. So here also, can I say that there will be rainfall throughout the year? Yes, because these are onshore maritime winds. So this happens to be observed and experienced around the region of Gulf of Mexico. So that is what is also referred to as Gulf type of climate. Climate. Here you have the China type of climate. In this area, you have the Mediterranean type of climate. And similar climate in the southern hemisphere, that is the natal type of climate. So let us study the features of them. So here the classification is CFA, CFB, CS, and CW. So CFA is the humid subtropical climate generally associated with the Gulf type of climate. Mostly associated with Gulf type of climate. This is what is mostly referred to as British type of climate. CS means rains only in winter. S refers to summer dry, only in winter. That is Mediterranean type of climate. Summer is dry. Now, yesterday we had taken a look at the region of Mediterranean when it came to the formation or the occurrence of Western disturbance. Now, in Mediterranean, we observed that during the winter months, there is frequent frontogenesis, right? So that is one of the reasons why the temperate cyclones in the Mediterranean during the winters in particular cause a lot of rains. Then you have the CW or China type where rains only in summer. Only in summer due to the shift of ITCZ. So that is the classification here. So CFA or humid subtropical climate that is present in the region around Gulf of Mexico, the eastern part of the continent. No dry season because this is the region where rainfall is received, onshore winds are received. So rainfall received throughout the year. Onshore winds. See, M and W, they are Sushmit, they are different because M, here you will have rainfall occurring in the form of a monsoonal condition, seasonal reversal of winds. Rainfall will happen during the summer, but here, when we talk about W, there you have no rainfall in the winter. In AM type, some amount of rains can still be received during winter if the monsoon phenomena lies in that phase, but mostly during the summer. W will generally receive lesser amount of rainfall as compared to an M type of climate. Okay. So examples are eastern US, southern and eastern Japan, southern and eastern China, Argentina, Africa, and Australia. Range of precipitation is between 75 to 150 centimeters. So this is the example of Memphis, Tennessee in US. So here you will observe that there is significant amount of rainfall which is observed almost throughout the year. So throughout the year, you have substantial amount of rainfall which is received. So that is the case of CFA. Then you have the CFB. This is also the British type. So here, basically, due to the marine influence, the temperature is moderate, and in winter it is warmer as compared to other areas along the same latitude. Here you have a greater marine influence. Western Europe, UK, these are the regions which experience this. So annual range of temperature or annual range of precipitation varies between 50 to 250 centimeter, and winters are milder. They are not extremes, right? So here you will have frequent frontogenesis and mid-latitude cyclones as well. So observe the region of London in England, daily occurrence of rainfall. That is something which is observed. This is the area primarily associated with CFB. This is the region to the west of Rockies where you have CFB. Some areas to the west of Andes, CFB. These are the regions of CFB kind of climate. This is 250 centimeter, not 250 millimeter. In certain areas, the rainfall is very high. Then the Mediterranean type of climate. Now, during the summer season, the Mediterranean region does not receive rainfall because the subtropical high pressure belt largely lies in that area during the summer season. So here, the basically you will have not much rainfall during the summer. So during summer, so the influence of subtropical high is experienced in summer. So that means no rains in summer. So if I show you the map of the region of Mediterranean, so during the summer season, here you have no rainfall because of the presence of subtropical high pressure belt. But during winter, let's suppose the subtropical high pressure belt shifts here during winter. So here you will have the westerlies. These westerlies will become onshore in the regions to the north of Ionian Sea, in the region to the north of Aegean and Mediterranean Sea. So this will create and cause lot of rains in the process. This will create lot of rainfall in the process. Yes, Lakshmi, London receives rainfall throughout the year on a daily basis. Precipitation is heaviest during the winters due to mid-latitude cyclones, extratropical or mid-latitude. Because remember, it is in the region of Mediterranean itself where we talked about the during the western disturbances, we talked about the extratropical cyclones being formed in the region of Mediterranean. There is hardly any rainfall during the summer. Temperature during summer is around 25 degrees and in winter is below 10 degrees. Generally, you will find fruit orchards and orchard farming. Orchard farming is basically when you indulge in growing fruits such as citrus fruits, olives, etc., that you grow grapes that you grow in large quantums. So orchard farming is predominant occupation. Okay, now then you have CW or the humid subtropical. Now here this is rains only during the summer. Winter is dry. So dry in winter, rains in summer. Basically, here in the eastern part of China, you experience this. So rains during the summer due to the shift of ITCZ. summer due to the shift of ITC set. Okay, till this portion, it is the important one. Now the D type is one of the least important ones. E type is still something that you can associate with. D type is the cold snow forest, where the winter temperatures, they fall quite significantly lower, right? So here you will have the trees also modifying themselves, conical shaped of trees, conifers. Now here also in the coastal areas, you will have rainfall throughout the year. In the coastal regions, you will have even DF type. Now, that precipitation can also happen in the form of snow, even though. But in the coastal areas, you can have rains throughout the year. Now, let's suppose at 40-50 degree latitude in the region of Europe, where we talked about, let's suppose this type, CFB, British type, the temperature will be much moderate here. But if I come to this region, winter will be very cold, Siberian high, right? Everything would get frozen. Summer will not be that warm. This region, for example, winters will be very, very cold, almost uninhabitable. So that is the D type. So D type, when you talk about, these are the regions of D type. Okay. Now here, it is the cold snow forest climate, which occur in large continental area of the northern hemisphere between 40-70 degree north latitudes in Europe, Asia, and North America. In southern hemisphere, you don't experience that D type in many of the areas. Why? Because in southern hemisphere, at these higher latitudes, you don't have the presence of land masses. Summers are typically warm, but can also be cool, while winters are cold. So during the summer months, average temperature reaches around 10 degrees Celsius, but during the winters, minus 15, minus 10, minus 20 also sometimes you will experience. So DF, DW, and DS. DF, rainfall throughout the year. So DF, cold climate with humid winters occur polewards of the British type and also mid-latitude steppe. These winters are cold and snowy. Frost-free season is very short. For most of the year, the entire land will be covered under ice and snow. Annual ranges of temperatures are large, around 30-40 degrees difference between the summer and the winter temperature. Winters become more severe as you go closer to the pole. So observe here, when you talk about the temperature conditions, for example, it is Winnipeg in Canada. During the summer, the temperature is barely around 20s, and during the winters, the temperature is around minus 20. So that gives you an idea about the variation. Okay? But rainfall occurs throughout the year in these coastal areas in particular. DW. So in the region of Siberia, where you will have some amount of rains during the summer, but during the winter, you have the establishment of Siberian high. So in winter, for example, winter anticyclone is formed in the form of Siberian high. I hope you recall it from module 7, where we discussed what is that Siberian high. And its weakening in the summer sets in monsoon-like reversal of the wind. Precipitation is around 12 to 15 centimeter only. That is enough for the growth of coniferous trees. Understand, if this much amount of precipitation happens in any portion in India, we experience conditions like Jaisalmer or the regions of Thar Desert. But in the higher latitudes, this much precipitation is more than sufficient. Why? Because the rate of evaporation is very, very less. Okay. Now, polar type. When we talk about the polar climate, so for example, in the regions such as, if you consider the polar climate, if I can show you the map. So in these areas, you will still have during the summer season some portion which actually melts. The top surface actually gets melted water. But in the interior areas of Greenland, in Antarctica, it is frozen throughout the year. This is also what is known as the tundra type of climate. Tundra type of climate. Okay. Now, polar climates exist polewards beyond 70-degree latitude. Temperatures are usually low all year round in the polar climatic regions. Warmest months see temperature less than 10 degrees Celsius, even during the summer. Barely it reaches 10 degrees. And in these areas of the polar regions, you experience this. This is again subdivided into EF and ET. ET is the tundra, so it is named after the type of vegetation. You have mosses, lichens, these are the ones which will grow. So this is the region of permafrost where the subsoil is permanently frozen. During summer, they have very long duration of daylight, where you will observe that during summer, when the actual tilt is towards the sun, it shines, there is sunlight even up till midnight. At 12 a.m., you will find the sun is still there. At 1 a.m., maybe the sun will set. Again, it will rise at 4 a.m. in the morning. So that duration of sunlight is particularly long in these polar areas. Then the this is the tundra type where you observe the temperature. This is the region of Alaska. Summer temperature is around 4 to 5 degrees Celsius at max. And winter temperature easily in the range of minus 30, minus 40 degrees Celsius. Easily. Okay. Then comes the EF or the ice cap. The regions which are permanently covered in ice throughout the year. For example, Antarctica, interior of Greenland. No summer. Throughout the year covered in ice. For 4 to 5 months, darkness. And then for the next 5 to 6 months, permanent light. Okay, so that is the case of EF. So even in summer, the temperature is below freezing point. Area receives almost negligible amount of precipitation. Here you will have, for example, in Antarctica, I hope this doesn't confuse you. In Antarctica, you have something which is known as the diamond dust phenomena, where in place of precipitation, you don't have that many cloud formation. You have different types of clouds. So, but those clouds don't cause that much precipitation, especially during the winters. But here, what you will have is that whatever amount of little moisture is there, it freezes into snow in mid-air itself. And that snow basically starts falling without formation of clouds. So that whitish snow particles, very small whitish snow particles, which tend to float in the air, that is what people in the region of Antarctica, they name it as the diamond dust. So here, if you observe the temperature at the McMurdo station in Antarctica during winters, it easily actually exceeds 45, minus 45, minus 50 degrees Celsius is the temperature which is easily attained in these areas. Okay, let us take a look at the questions. All of you had the basic doubt what kind of questions. Let us take a look at the kind of questions. Seasonal reversal of winds is a typical characteristic of which climate? Okay, I won't read the question. Yesterday, one of you had requested me not to read the question. So read the question and let me know of the answer. This should be easy. Laghima, why the southern hemisphere does not have cold climate? Because in southern hemisphere it has cold climate, but the D type of climate is not very predominant as compared to the northern hemisphere, because in these higher latitudes you don't have much landmass. In the southern hemisphere you have water body. That is why. Lakini, yes, it is the coasts. Good. Majority of you have given the correct answer. Seasonal reversal of winds is a characteristic of what? Where the winds are moving like this in one season and then in the other direction in another season. It is the characteristic of monsoon climate. Okay. Now, take a look at this question. I will not read it. I'll give you 1 minute. Let me know. You have two statements. Yes, Garima. Good. Correct. Ankush. No, Ishita, wrong. Dikshit, wrong. Again, somehow majority of you have managed to give the correct answer. See, this is where again observe the trend in the previous questions also that we had discussed. Remember, I told you they will replace just one word or one letter, which will make the entire statement incorrect. So, in the first statement, the winds which blow between 30-degree north and 60-degree south latitude throughout the year are known as westerlies. Is there any wind system which originates from 30-degree north and continues till 60-degree south? Is there any wind system? No. Had this been north instead of south, had this been north, the entire statement would have been correct. This is where that lack of concentration comes into play. Earlier, also, I told you with the case of the IOD, the El Nino type of questions, that they will just change Indian and Pacific and the entire statement becomes incorrect. So, this is the catch here. This becomes incorrect. So, UPSC is banking upon this, that you will commit error in this. So, at the end of it, you cannot come out of the exam hall and say, you see, I knew it, but I did a silly mistake. That is what UPSC is trying to achieve here. And if you commit a mistake, UPSC has succeeded. The moist air masses that cause winter rains in the northwestern region of India are part of the westerlies. The western disturbances are brought by the westerlies. This is correct. So the correct answer is going to be B, 2 only. So all those who have caught this particular sign, well done. And also, please continue to be careful. Which of the following is the characteristic climate of tropical savanna region? Rainfall throughout the year, rainfall in winter only, an extremely short dry season, a definite dry and wet season. Seema, is this throughout the year? What is throughout the year, my dear friend? Westerlies. Westerlies are throughout the year. Western disturbance, if you are asking, that is only during the winters. Yes, Karima, correct. Ankush, correct. Good. Majority of you have given the correct answer here. So, tropical savanna is basically a W, means winter dry. Winter dry. So, rainfall throughout the year is experienced in equatorial region. This goes incorrect. Rainfall in winter only is incorrect. An extremely short dry season means it rains throughout almost for most of the year. Very short time it is dry. No. For a longer period, it is dry. It rains for a shorter duration. So the correct answer will be D here. Consider the following statements. And you read the statements. Okay, let me know. If you want, I'll give you 1 minute for this also. Majority of you should get it right. Yes, Checha, correct. Lakshmi, wrong. Dikshit, correct. Yes, Ankush. Seema, correct. Good. Majority of you have given the correct answer. Duration of monsoon decreases from southern India to northern India. In northern India, the monsoon reaches late, withdraws first. Then the amount of rainfall in the northern plains decreases from east to west because you move away from the source of moisture. So both of them are correct. Correct answer is going to be C. Now, apply your logic. Don't come under pressure in this question. During a thunderstorm, the thunder in the skies is produced by. Select the correct answer using the codes given below. Why is a thunderstorm produced? 30 seconds should suffice. Yes, Karima. Correct. Seema, correct. Mega, correct. Ankush, Gurcharan, wrong. Dikshit, wrong. Chetsha, correct. So majority of you have given the incorrect answer. So here, you should be proud of yourself. Why is it that thunder in the skies occur? That thunderous sound. Why does it occur? Yeah, you needed more time. Anyways, so fair enough. It will be sudden expansion of air. Lightning occurs because of the charged particles. Thunder occurs in the region of lightning because of sudden expansion of air caused due to lightning, due to heat produced during lightning. So, meeting of cumulonimbus clouds in the sky. From our childhood days, the problem is many of us have been told at various levels that the clouds they will collide and that is why you hear the thunder. So still at this age, many of us we tend to believe we are not able to remove that preconceived notion. But I hope gradually when you study geography after you have covered this portion, I hope that is no longer the case. Lightning that separates the nimbus clouds, no. Violent upward movement of air and water particles, no. It is the sudden and the violent expansion of air. Okay, this is a question we have already discussed. Each day is more or less the same. The morning is clear and bright with a sea breeze. As the sun climbs high in the sky, you read the question. How much time do you need? Do let me know. I'll give you 1 minute for this. Read the question. Let me know about the answer. Pooja wrong. Megha and Seema correct. Take your time, guys. Take your time. Don't rush. Tabassum, Gityon, Ankush correct. Vishant correct. Sapna, Lakshmi, Gayatri, Pooja. Pooja, earlier you had given wrong. Garima, Gurcharan, Diksha Rajpurohi, Sushmit correct. Chetsha and Dikshit wrong. Yes, Dikshit. Abhishek correct. Hema correct. Good. Majority of you are correct this time. So each day is more or less the same. Means duration of daytime and nighttime is almost similar. Temperature is almost consistent. Morning is clear and bright with a sea breeze. As the sun climbs high in the sky, heat mounts up. There is convection. Dark clouds form, and then rain comes with thunder and lightning. Means every day you have cumulonimbus clouds causing rainfall. But the rain is soon over. So, which type of climate? Equatorial climate experiences these conditions. Okay. Why are dewdrops not formed on a cloudy night? Again, take 1 minute. Or I think 30 seconds should be sufficient. Yes, Anjan, you are right in this. So 30 seconds should be sufficient. 1 minute. Okay. Take 1 minute. Good. So basically, here again, majority of you are correct. So if you have clouds, these clouds will re-radiate back the terrestrial radiation. They will raise the temperature of the surface. If the temperature increases on the surface, it won't allow the dew formation to happen. So clouds reflect back the Earth's radiation will be the correct answer. So leaderboard, before you start the clamor call, I will show you the leaderboard. Vishant, Gayatri, Lalita, and Ankush. Very good. Gityon, Sushmit, Megha, Seema, Varsha, Lagima, Nancy, Surbi. Good. Vikram. Good. Very good, guys. So that brings us to the end of climatology. I hope we have taken climatology as slow as we can. I hope that is understood, that is understandable. It is a concept that you revise and you basically become proficient in that. There are no two ways around it. Now, coming to the portion of oceanography, where again, just like in the climate, we studied the world with the help of the climate. In terms of geomorphology, we studied the world with the help of the different topographies of the world. Here, we are going to study about the oceans across the world. Now, the entire planet is referred to as the blue planet. Planet Earth is one of those planets which consists large amount of liquid water in the form of oceans. These oceans have been witness to the genesis of life on the planet. I hope we are aware that life germinated, life evolved for the first time underwater. It is from water that life eventually populated the land mass also. So the oceans, they are the providers of life. Regardless of what they appear from the surface, these oceans, they have much of turbulence that is included within them. You have various different types of motion, different types of waves, currents, tides, etc., which are generated in our solar system, and basically in the entirety of the observable universe that we have managed to examine. Planet Earth is one of those areas where you have liquid water in the form of oceans. It is suspected, by taking a look at the region of Mars, it is suspected at one point of time Mars also might have had liquid water. It is suspected by looking at one of the moons, Europa, that basically Europa has got ice on surface, and underneath that ice, it is suspected to have liquid water. But nowhere do you have this kind of a surface ocean water. Oceans represent close to around 97% of water across the planet. That is represented by the oceans. So here we are going to study it from the perspective, just like in the case of the climatology and geomorphology, from the very basics. We will move ahead with the concepts, and we will keep on evolving in these concepts. So first of all, we'll study about the physical properties or the bottom relief of ocean. Bottom relief features of oceans. Then we would study about the case of even physical properties of oceans. Here we will study the property of temperature, salinity, density. Then we will study about movement in oceans, waves. Very briefly, we'll cover the portion of waves. Then we will cover tides, ocean currents, and we'll study the portion of the current predominant areas which have been in discussion for the past couple of years, which are relevant for your examination. Global conveyor belt, Atlantic Meridional Overturning Circulation, or AMOC. Okay. Now, for your prelims, out of these, if I were to refer this portion, this particular portion, These are relevant for your prelims. Whereas for your mains, other than the wave portion, everything is relevant for your mains. Other than the portion of waves. Waves are generally not frequently asked either in the prelims or the mains exam. Now here, when we talk about these particular portions in oceanography, understand oceanography is a kind of a low-hanging fruit. Oceanography is where at least the candidates who will succeed in the examination, they will never commit mistakes here. Because that scope to commit mistakes in oceanography is very less. Right? You have very direct sort of questions. In climatology, still UPSC can twist. In geomorphology, still UPSC can put such difficult wordings in between that you will lose your mind. Oceanography, UPSC has got no such scope. Very direct questions are asked. That is why your competition will never commit a mistake in oceanography. So you should also not commit a mistake in oceanography. And it is difficult to commit a mistake here because it is that easy. Okay? I will show you the questions eventually and you will be able to understand. Starting first of all with the ocean relief, the ocean bottom relief. Now, from your childhood days, basically, when you would have seen a map or the globe, you would have seen large areas painted blue, right? From your childhood days, you would have been taught this particular lesson that use the color blue to paint the oceans, and you would pick up the blue crayon and rub it all over the map. Now, for a long period of time, our understanding of oceans was what we saw on the surface. What we saw on the surface was basically calm conditions. So everybody thought that the bottom of the ocean should also be flat and featureless. It was when, during the era of the Second World War, when discoveries and inventions basically were made for the various equipments which could study objects underwater, that is when the secrets of the oceans that started unraveling. Having said that, I don't know if you are aware of not, but you should be aware, and many of you would be puzzled and amazed by this particular fact, that today we have a high resolution image of almost every place of the moon. Today we have a high resolution image of almost every place on the Mars also. But we cannot say the same for the ocean bottom. We have not managed to explore every area of the ocean bottom. That is why ocean bottom is still full of many surprises. Ocean bottom still consists of evidences of life which evolved in these areas hundreds of millions of years ago. Because the conditions at the ocean bottoms, they have largely remained consistent for hundreds of millions of years. So that is why there was a detailed article in the Economist magazine where the ocean bottoms were referred to as the final frontier, where mankind's scientific prowess has still not managed to take us to the bottom of the ocean. While we plan to settle colonies on Mars, while we plan to habitate the moon, we don't know what lies at the bottom of the ocean across the planet. But ever since that era of discovery from the Second World War was observed, one thing that we know for certain is the fact that ocean bottoms, they are not flat and featureless. They have a series of various features. And if you observe any of the physical map of the world carefully, you will be able to observe that every place is not in the same shade of blue. Why do you think that is the case? Is it because it was a printing error? They ran out of ink of dark blue, that is why some areas are lighter blue? No. This represents regions of various depths. The areas in dark blue that you see, the areas in dark blue that you see, these are the regions of very deep waters. The areas of light blue that you see, shallow waters, not at all deep. These regions that you see, these are your mid-oceanic ridges, underwater mountainous areas. These form a continuous chain which spreads across the planet over a distance of more than 64,000 kilometers. These underwater oceanic ridges or underwater oceanic mountains. You have features like seamounts. What are seamounts? Seamounts are basically underwater. You have these mountains. These are your seamounts. But oceanic water, as it moves around these regions, they will erode, they flatten this up, and then you have these unique flattish portions underwater. This is the surface level of water. These are your seamounts, underwater mountains, and these are what are known as goyads. So there are a series of different types of landforms. So when we talk about ocean relief features are basically a sum product of the topographical features or the geomorphic processes that lead to the formation of various different types of landforms on the surface of the continents. So such kind of geomorphic processes, a similar kind of geomorphic processes, they lead to the formation of various features underwater also. So here, basically, almost all the oceanic relief features, they are either tectonic in origin, volcanic in origin, or erosional and depositional process. Erosional process or depositional process. For example, tectonic. Tectonic processes end up creating ocean trenches. When you have convergence of an oceanic plate, either with an oceanic plate or another continental plate, trenches are created. Volcanic, mid-oceanic ridges are created because of volcanic processes. Ridges, then seamounts are created due to volcanic processes. Then due to erosional and depositional processes, so let me classify or differentiate that. Due to erosional process, first of all, you can have submarine canyons, goyads, continental slope. These are formed due to erosional processes. Depositional processes, these will create continental shelf. In some places, they can also create continental rise. They can create deep sea plains, what are also known as abyssal plains. Okay, so almost all the variety of relief features that you find underwater, you will find that there is a geomorphic process behind it. So the natural question which can be derived from this area is that a statement based question in the mains examination, that oceanic relief features are a sum product of geomorphic processes. Elaborate. So there you will have to talk about the tectonic, the volcanic, the erosional depositional processes, how they end up creating these individual landforms. With the help of example, you have to elaborate along with the diagrams, obviously. So that is going to be a straightforward, simple answer. Okay. So let us take a look at the division of the ocean floor. So basically, when we talk about the division of the ocean floor, you have continental shelf, continental slope, deep sea plain, and the oceanic deeps or the oceanic trenches. These are your major classification. This is the major classification. Sir once explained the submarine canyon. So should I not explain the other portions, only explain submarine canyon? Is that the request? Sushmit, it can be included, yes. Mostly the ridges are volcanic in nature, but it can be included in tectonic also and also the volcanic, but mostly volcanic. Can I say that the regions of seamount was land area in the past and is now converted into sea? No. Or is it made, it was made in the water by volcanic phenomena? The second one, Lakshmi, will be the correct assumption. So these are your major classifications. Relief features. And then simultaneously, you also have many of the minor relief features like ridges, hills, seamounts, guyats, trenches, canyons, etc. They are also there. So here, first of all, when you take a look at the region of the ocean, it is not as if where the water starts, it is very deep there itself. Okay, it is not that case. Now, at the deepest or in general, in where you have the water which is very deep, the bottom of the sea floor. I'm not talking about the ocean trenches. Ocean trenches can be 11 kilometers below the sea surface, 10 kilometers below the sea surface. But normal ocean floor lies at a depth of around 4 to 5 to 6 kilometers below the sea surface. 5 to 6 kilometers below the sea surface. That is a lot of depth and that is a lot of water. But here, it is not the case that immediately from the shoreline is the existence of that boundary where you have the water almost coming in. That is your shoreline. Okay. Abyssal plain is included in the major divisions. That is basically the deep sea plains. They are known as abyssal plains. Wait for it. I'll come to it. This is the abyssal plain. Now, if you observe, immediately across the coastline or the shoreline, it does not get very deep immediately. It continues with a kind of a slope. This is a continuation of the continental area in itself. This is where you have the land, which is somewhat like this. So you would also have experienced, if you go to the coastal areas, you would also have experienced that you can walk a few feet. Water comes slowly and steadily up to this level, and maybe around 10 feet, 20 feet, 30 feet deeper water will be closer to the coastline. You can drown in even 6 feet water. Even 6 feet of water is enough depth to drown an adult individual. If the waves they come to play and if the winds they are strong, 6 feet water is deep enough. So don't compare it that but you are saying the water goes deep. When I went to Puri, I could stand there at a region where nobody could dare to. So still every region is around the area of continental shelf that you witness, that you venture out. So this is the region which is mostly a product of the deposition. This is the shelf, continental shelf. It is an extension in terms of slope characteristics of the continental landmass itself, created largely due to deposition. Its width is not fixed. As you can see, in certain areas, it can be very narrow. In certain areas, it can be very broad. And in many of the areas, the continental shelf can almost be absent. For example, let's suppose here you have land. Let's suppose the coastline is flatter, this type. So the shelf area will be very wide in this case. But what if across the coastline you have a mountain or a hill-like feature? Then what? Here, if you have the ocean, then will there be a substantial continental shelf in this area? No, it is almost absent here. Right. So depending upon the slope of the coast also, you will have the extent of the continental shelf which varies. For example, in the region around Siberia, if I can take you to this map, previous map, in the region around the Arctic shelf, observe how wide these shallow waters are. These shallow waters, they basically represent the region of the continental shelf. Okay. Now observe this continental shelf around here, where you have mountains on the coastline or mountains along the coastline. Shelf is almost absent. Okay, so the slope decides the extent of the continental shelf. Eventually, the shelf ends in a region that is what is known as the shelf break. Wherever the shelf is ending, that is known as shelf break. By the time that you reach the end of the continental shelf, the water will be around 100, 200 meters deep. That's it. Not very deep, 100 to 200 meters deep. Now, across the globe, when you consider all the oceans, the continental shelves, they represent only around 7 to 10% of the area of the oceans. Okay, the shelf represents only 7 to 10% of oceanic area. Most of the area is occupied by the deep sea plains across various oceans. But even in that 7 to 10%, they account for more than 90% of the biodiversity of the oceans. Account for more than 90% of biodiversity of oceans. Okay, why? Why is it the case that in continental shelf you have so much biodiversity? Very simple reason. In continental shelf, the depth is very less, so sunlight will be able to penetrate. If sunlight is able to penetrate, you will have marine plants which will grow. Now, these marine plants which will grow will have the ability to support the life forms also. Marine life will come where the plants are there. That is where you will find large biodiversity. So, obviously, historically also, these shelf regions were the ones where a lot of biodiversity, a lot of various of these animals, they would have died, they would have been deposited over multiple layers. And the dead marine animals lead to the formation of which mineral? A prolonged compression and deposition of the dead marine animals lead to the formation of which mineral? Very good. Coal. Coal is formed by wood. It is basically crude oil and natural gas. We have talked about it previously also. I hope you don't act surprised with this because we have talked about it in very significant detail previously as well. So it is the case of petroleum, natural gas, or the crude oil and natural gas. So many of these shelf areas will also have significant amount of reserves of fossil fuel or crude oil and natural gas. Now, then beyond it lies the slope. Suddenly it gets deeper. It can get deeper up till 3 kilometers, 2 to 3 kilometers. Now, everything brought by the oceans from this area eventually is dropped here. And in certain portions of the ocean, not everywhere, in certain portions, these get deposited. And these deposits, they form the continental rise. So here, observe the slope characteristic. Slope is very less in the shelf area. It increases suddenly in the slope area. And then again, you have deposits in the form of continental rise. That continental rise is not present uniformly across all oceans. It is present only in certain areas, wherever the oceanic waves and water are able to bring those back. Then you have the abyssal plain or the deep sea plain. So this up till the portion of continental rise, it is known as the continental margin, and then the oceanic crust is the one which predominates. So starting with the continental shelf. Continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. This is the shelf. Okay, aided by the shape of the coastline also, the topography of the coastline also. The depth varies from 30 meter to 600 meters, but the extent is not uniform. The average width is around 80 kilometers across the globe. In some cases, it is not even existent. For example, in the coast of Chile, west coast of Sumatra, and the largest shelf area is present, for example, in the Arctic shelf around Siberia, where you have the shelf of around 1500 kilometers, the very rich source of fossil fuel. Now, on the coast of Chile, I had asked you to mark an oceanic trench in that area. Can anybody tell me which oceanic trench is present in that area of the coast of Chile? Very good. Rani, Anjan, Krishika, Mansi. Beautiful. Brajneet, Shreyas, correct. And rest of you, now please don't answer because now it is enough time to search it on Google. So it is the Peru Chile Trench. Peru Chile Trench. So there also. So that tells you that the shape of the coastline, the topography of the coastline, if it has mountains and trenches nearby, it will be very deep. Shelf typically ends at a very steep slope called the shelf break. The end of the continental shelf that is referred to as by the name shelf break. It is a source of fossil fuel, that is crude oil and natural gas. In fact, wherever crude oil is found, we have talked about it previously also, that means that region has existed underwater at some point of time or the other. Wherever limestone is found, again means that region has remained underwater at some point of time or the other. Okay. Now you have continental slope. So at the end of the shelf begins the continental slope where the gradient suddenly increases. So it indicates the end of the continents, connects continental shelf and the oceanic basins. The depth starts from around 200 meters and reaches up to 3 kilometers in depth. Canyons and trenches are observed here. Now, here in this area, you observe something very unique. Observe this area on the map. Observe this. The submarine canyon. Submarine means underwater, a canyon like structure that you observe on the land also. But it has got a kind of a dendritic or a sinuous pattern, a linear pattern to it. Now, there was a lot of controversy around these submarine canyons in the geographical community for a long period of time, that how they were created. How is it that these deep canyons, basically, if you take a look at it, submarine canyons, these are very narrow, deep structures with steep walls on the sides, and they are very long. Starting from the shelf area, they can extend many kilometers into the slope area also. So the geographers always wondered, how is it that these submarine canyons were formed? There were two schools of thought. In fact, there were various schools of thought. One point of view was that, look, wherever you observe a major river, that major river will drag the sediments and the silt. And that sediment and silt will move in a particular direction underwater also. And they will erode the subsurface or the sea surface. And they will create that erosional structure. This was accepted. That, okay, wherever you have large rivers, we are observing these canyons. Now, it was also found that these canyons are also to be found in areas where there are no rivers at place. How were they formed? So some school of geographers, they came up with the opinion that, look, these areas where you have the canyons where you don't have any rivers anymore, these areas would have been at one point of time above the water level. And that is when the erosion would have created those canyons. Now the water level has increased and those areas have been submerged. Ridiculous explanation. Did not fit the bill. However, for the process of formation, the first point was accepted. Formation, the first point was accepted. At the mouth of large rivers. For example, if you observe the map, if you can observe this map itself, here, I want you to observe carefully. I hope this map is visible to everyone. I want you to observe the map at the mouth of river Ganga. Here. I hope you are able to see a kind of a line in the light blue or the whitish waters here, where the water is not very deep. I hope you are able to see a kind of a line there, right? This line, not the delta formation. This line, I hope you are able to see this line. Right? Then look at the mouth of river Indus. I hope you are able to see this small minor fracture of a line. Yes? Is it visible to everyone, everybody? These are your submarine canyons. Canyons which exist underwater. Which tells you what? That wherever you have mouths of larger rivers, there is a process of erosion carried underwater on the sea surface, which is eroding the materials on the shelf, on the slope, creating these submarine canyons. Even across River Mahanadi, River Godavari, Mississippi, all these are the regions where you have these kind of submarine canyons. Fair enough. It is acceptable and it is logical also. But here, by the process of erosion, you can have this. But what about the other places? You have the presence of these canyons at other places where the rivers also don't exist. How is it that there the submarine canyons are present? So that was because of a theory which was provided due to the presence of turbidity current. Now, what is that turbidity current? Turbidity Again, is derived from the term turbulence, turbid waters, where you have a lot of a kind of a violent movement in water, etc. Now, what is this turbidity current? So, in general, if you have ever been to a coastline, if you have ever seen a video of a coastline, you have imagined a coastline, anything, what do you observe? When the sea wave comes in, it goes back. As it goes back, all the loose materials are carried by the sea. All the loose soil, sand particles, they are carried by the sea in their action back. They might bring a new set of sediments to the coast again, but they will carry that back as well. So there is that backward movement towards the sea portion. Backward movement of what? Of sand particles, small rock pieces, gravel, pebbles, everything is dragged back by the sea. That is how the sea waves carry out erosion also of the rocks, everything. So here, can we imagine a kind of a situation in the coastal area where, if you consider the sea waves and the movement of the sea, can we imagine a situation where there is going to be that downward flow or the backward movement of these pebbles, rock pieces, mud, sand, everything in this direction? Movement of sand, rocks, pebbles, gravel, etc. We can think about it that these will move back. Ketan, please pay attention to this now, because later on you will not understand the portion of submarine canyons and you will have a problem there also. Okay, where petroleum is found, I will tell you. I have already told you, I'll tell you again, but please pay attention to what is turbidity current. I'm sure you are not paying attention to this. So listen to this carefully once again. So here, as these waters they go back, they will drag from the coastal area these rock particles, these sand particles, gravel, sand, everything. Now imagine this is the slope of the sea surface or the bottom surface of the sea. These particles, aided by gravity, will keep on rolling down. Not every place they won't roll down with the same uniformity at every place. In certain areas, there will be a greater concentration of moving back. In certain areas, lesser materials will go. Repetition of this movement day after day, week after week, year after year, millennia after millennia can lead to creation of a small indenture, a small eroded structure here. Now, if you have a small eroded structure, sand sediment from every area will use that channel to flow back. It will be like a current of movement. That is the turbidity current. Sometimes that speed of movement can gain a velocity of 45 up to 45 to 50 kilometer per hour, right? Up to 45 to 50 kilometer per hour, it can gain a speed of that, isn't it? So what that repeated motion does, that repeated motion carves out an erosional structure with narrow walls on the sides. That is the submarine canyon. Is this understood? Repeated movements in the direction of the slope. Slope carves out erosional canyon-like structure with narrow walls, narrow and steep styles. That is what is known as the turbidity current, and this formation is known as a submarine canyon. Right. So here, as one of you have asked this question, that is apt also. Why in only one area we have the submarine canyon? Ideally, I observe the coastal area. The sea wave carries things back everywhere. But if you notice the coastline carefully, not everywhere is the action of the sea, what is known as a backwash. Not everywhere is it that strong. In certain areas, it is very strong, where you will observe that materials from even this area, they go back in this pattern. Observe it next time. So that is basically aided by the topography of the shelf. Because the shelf is not a flat portion. The shelf can also have indentions. So wherever there's a kind of a depressed area, all the materials will start flowing through that area, deepening that region by repeated motion, by friction. And that is why, and that is how they will carve out a deep canyon. But what is the reason of this uncertainty? Which uncertainty? That where it will flow back. It is the topography of the continental shelf. Continental shelf is not flat. Continental shelf has got certain regions which are upraised, certain regions which are downgraded, certain regions which are flattish. So wherever you have that downgraded, even across land masses, when it rains, associated with the case of the land masses, when it rains, does water flow in a uniform manner across the entirety of your city? No. Water forms certain channels, flows through certain areas. What decides where the water will flow from? The slope, the gradient. Across the roads, is it the case that across the entirety of the road it is a river? No. Maybe in the central portion the water starts draining, or the side portions the water starts draining. Why? Because that there is a variation in topography. Similarly, in the case of the shelf also, there is that undulation, due to which in certain areas around the depressed regions, there will be a maximized flow. And that repetition will further exaggerate it. Earlier, it might be the condition that the shelf area would have a topography, let's suppose, would have a topography somewhat like this. Repeated motion across this area would have carved out a deeper portion here. Then the deeper portion means all the more materials will drain out from this area only. So that is how the canyons get created. I hope it is understood. How much is the depth they normally have? So these submarine canyons can be around more than sometimes 10 to 15 meters deep from the sea floor. So they can be 10 to 50 meters deep. So if the sea floor is at a depth of around 100 meters in that area, you can expect another 100 meters depth. Okay. Sometimes they extend all the way through the region of the continental slope also. So there they are at a depth of 3 kilometers from the sea surface. Now, can it be more than one submarine canyon made on one coastline? Absolutely yes. On the eastern coastline, you have the submarine canyon made by Mahanadi also, Godavari also. Okay. And Lakhney, turbidity current is the water flowing in the depression created by eroded materials. Yes. That flow of water along with the eroded materials, that flow, that is the turbidity current. Okay. And continental rise prerna is basically when you have the eroded materials brought from the shelf and the slope area, when they are deposited immediately at the bottom of the continental slope. That is your continental rise. Okay. Right. Okay. So that is basically where we'll restrict the session here today. Now, Ketan, your question was that petroleum doesn't exist around Indian coast. So here, basically, across the Indian coastline, my dear friend, if I take you back to the map of the Indian coastline, are you there in the session, Ketan? Observe where the oil is found. It is found here in the region of Bombay High. It is found here in the region of the Krishna Godavari Basin. This is across the coastline. On the mainland, you'll find it here, very close to coastline in the Jamnagar region, here in the region of the Bikaner area, here in the region of Assam oil fields. That is the petroleum and the crude oil distribution. The Mumbai high oil fields are here, Shreyas. You told sea wave landforms are these different from oceanic landforms? Yes. The landforms created by the sea waves that you see are on the land. This is the landforms underwater. Okay. Anjan continental shelf in eastern coast looks more flatter than the western coast, which has a wider shelf. Why is it that despite having a significant vertical slope across the western coastline, the western continental shelf in India is much wider? And why is it that despite having a flatter land across the eastern side, continental shelf is very narrow? Think about it. Let me know tomorrow without searching. Shallow sea means that it is not very deep. Sea Mount Chetcha is underwater mountain. Rani, correct. Sushmit, that too also Sakshi, correct. So, Sushmit, if that is the only tough portion, then it is not tough anymore. Because jet stream also formation, if you just read it again, it will be very, very easy. Formation of sea mountain, Ketan, is because of underwater volcanic eruption. Remember when we talked about the oceanic convergence? There we observed that underwater volcanic eruption, if it continues, it can form islands. Otherwise, it will form a restricted underwater mountain in the form of seamounts. That is why I had given you yesterday the task of mapping the Emperor Seamount region. Why it is not straight, Lakshmi, the submarine canyon? Because ever will the erosion ever follow a straight line? No. Geometrical patterns, they are not followed in the case of erosional structures. Is every continental shelf area have fossil fuel reserve? No. But many of the areas have it, not every area. Depends which areas have experienced in the past the mass die-off and deposition of marine organisms. Can volcano come underwater? Yes, mid-oceanic ridges are the example of volcanoes underwater. There are many such volcanic eruptions underwater. It is these volcanic eruptions underwater which basically continue to happen, where the volcanic deposits continue to happen even beyond the surface of the sea to create the islands. So that is where we'll restrict the session. We meet again tomorrow. Take care of yourself. Goodbye. Thank you and have a good night.